And we're live with our 174th episode of Absolute AppSec. I'm Ken Johnson at CKTricky on Twitter, joined by my co-host Seth Law at Seth Law on Twitter. Seth, say hi.
Hey, everybody. Welcome back to another episode. We're happy to be here, excited to be here as always. Got a few things that we want to talk about from this last week's news. Before we jump into that, though, I do want to make sure everyone knows. Obviously, if you've been listening to the podcast for the last couple of months, you know that we were going to be at LocoMocoSec teaching practical secure code review. I invite you all to come take part there. If you can, come sit on the beach with us for a couple of days. LocoMocoSec is going to be a fabulous conference, as it is. No better place to go learn about secure code review than the beach. So come participate if you would like. In addition to that, we will be training at DEF CON. So DEF CON is offering trainings the 2 days after the conference, so as not to conflict with Black Hat and other conferences that run before. But the Monday and Tuesday following DEF CON, they will be having paid trainings. Practical secure code review is on the list. So if you're going to be in town for DEF CON and Vegas for DEF CON, please consider us. We would love to, fill that course up as well. LocoMocoSec is filling up. So, if you're interested, if you're on the fence, jump on it. Outside of that, Ken, is there anything else I'm forgetting? Outside of the fact that I need to send out new shirts, I've had a couple of requests for those.
I think that there is something that I'm forgetting, but I'll if I remember it during the course of this podcast, I'll bring it up. So there is something I'm forgetting, but anyways, I'll figure it out.
There is. If someone can guess what Ken is forgetting, then I'll send you a t-shirt. Okay, there you go.
It's just going to be all insults in the comment. It's fine.
Yeah, exactly.
Forgot to shave, forgot to bathe. I don't know, whatever. Cool. Yeah, no.
So the first thing we wanted to talk about today, this is, honestly, this space, the Web3 space, Ken and I have been talking a lot about this recently. Part of the reason, at least for me, that this is so fascinating is the fact that the code review that we can do is on public code, right? So we start talking about smart contracts and other things, distributed apps. It's all public code, but it processes massive amounts of money and data. And the smallest nuance of a, what do we always say, Ken? The smallest framework nuance, language nuance can have massive financial consequences, right? So we keep talking about these large breaches, these large transfers of money on different blockchains and on different cryptocurrencies. And it's usually the result of a smart contract that has not either been properly vetted, that no one did any, secure code review on, or maybe the analysts that reviewed it didn't do proper threat analysis. I don't know, but that's part of the reason. That's one of the things that I find so fascinating with these environments, Ken, is the fact that we have smart contracts that are signed, publicly known, and all the code is out in the wild, right? There's no hiding it, which means there's no hiding the bugs when these happen. So the analysis that happens after the fact is fascinating to see how it actually occurs, right? I don't know about you, but that's one of the things that I find so interesting about it.
Yeah, I think the analysis is interesting. I think that what's to your point, I think the fact that traditional, I wouldn't say traditional, I guess not traditional web security, but just traditional sort of flaws in programming, not just web security, but just security, or even just programming flaws. These are the things that are biting smart contracts pretty hard right now. And also the fact that the impact for, bugs are much higher when you're talking about a financial system like this. I mean, we're seeing hundreds of millions of dollars being exfiltrated pretty regularly, which in my mind, it destabilizes the whole concept, you know. And so in trying to be quick about building these smart contract technologies and platforms, there's a balance between speed and introducing some pretty serious flaws that not only affect your customers, but in my mind, reduce the integrity and the whole purpose behind, you know, smart contracts, that the whole financial system that it's kind of built upon. So I think it's very interesting, but also it's just the same stuff kind of being, you know, repackaged in a different way.
Yep.
Yeah. So,
Yeah.
and the one that you're going to point to, I think is it's easy to understand.
It is.
And
it
the impact
is
is so high. It's so bad. So,
yeah. And this is one of the, like, if you look at there's lists of, like, you know, the top 5 or 10 issues with security issues with smart contracts. And I mean, this is definitely on that list. Right. So, and it's not like this one's been out for a while, or it happened just over a month ago. Right. This Rike, whatever.
neither of us could figure out how to say it.
Say it. That's how plugged in we are with that, that section of the, I mean, there's so many different chains and currencies.
There really are.
It's almost impossible. Yeah. But the article just does a quick walkthrough on it. I mean, I think they made away with about, like, the attackers made away with about $1 million. And it's realistically just an access control issue. But I mean, Ken, what were your initial takeaways on this, on the walkthrough here?
Yeah, I mean, it's the classic allowing user supplied input to have, you know, basically to control the flow of the application, right? That's really what it all comes down to. They set this function as externally accessible, so it's an interface that somebody can interact with. And when you do that, and you're taking information that's used to direct traffic in terms of, you know, smart contracts, pretty problematic. So it's an interesting. It's interesting, I guess, in the sense that we are seeing some of the things that, like I said before, it's more interesting in the fact that, like, these are the same things we've seen before. It's just once it applied a little bit differently in this new technology stack, which is interesting considering it's supposed to be, like, you know, secure. It's supposed to be it's supposed to prevent fraud. Again, it's interesting in that sense as well. And, you know, yet the same old stuff is affecting these providers. So yeah, I guess that's the most interesting bit. But do you want to dig into, I mean, I don't even know if there's that much to dig into, technically speaking. But I guess we can, do you want to share screen, or should I share the screen, or?
Sure. Let me see if I can share right now. Oh, I can. Sweet.
And I have to say, like, I have a question while you're pulling it up for you. Because I know you have done a ton more lately in reviews of this type of, basically you've been reviewing Web3 things and smart contract type transactional sort of services. And so curious to hear your perspective on, you know, what you're seeing. Is it still just like traditional flaws, or, I mean, is it more nuanced mathematical cryptographic operations? I mean, what are we thinking here?
So I don't know if this is just my, my training, right? Like my experience, but I definitely, like, we see a lot more. Well, okay. It's kind of twofold. We've seen a lot more issues from those traditional attacks. So similar to this one that we're going to talk through here shortly, where we're giving the users, or we're trusting the users with too much, ability, right? Like, this is an access control issue. They should never have been able to change an address or change the functionality of a smart contract function. and yet they were able to do that. This is more the sort of thing that we're seeing. I know that cryptocurrency in general is based on very difficult, algorithms and encryption and hashing that goes along with that. That seems to be a harder nut for all of us to crack, right? So there's, there's just the number of people that understand what's going on in that space is very, very small. So I know that there's more issues that are there, but we haven't seen as many of those. Most of it has to do with things like key handling, default, like addresses, like being able to specify addresses that end up as like a nil value and just transfer money into the ether, like stuff like that. That's kind of, it's almost like programming 101 errors that we're having. And the fact that we're asking people that understand like the deep, like cryptocurrency transactions to go and implement basic security protocols that they haven't studied for the last 10 years, right? We're just kind of, we're having this moment in the Web3 space that's very similar to what happened in the web space and with developers in general, like back-end developers back when SQL injection was a huge issue. There's no guardrails, there's no frameworks that protect against these sorts of attacks. And so people make that mistake and then they lose millions of dollars. So I guess my short answer is I see more of just kind of the standard stuff transferred to a new platform. Sorry, what were you going to say?
No, well, what I got from what you said too is that it sounds like, because, we talk about how when you do assessments, you want to get a pretty good understanding. You need to get the context, right, of what you're dealing with. And that's the high level way of saying, in this case, I would need to understand how crypto financial transactions occur. For you to, even though the underlying flaw here is pretty simplistic in terms of just an interface that's set, externally accessible where you can set the Oracle value, like, sure, that sounds pretty simple, but then you actually need to understand how lending occurs on the blockchain and how basically how the financial world of crypto works, really, honestly. And that's part of getting that context. And once you understand that context, it's easy to take our traditional knowledge and say, okay, well, yeah, these are the types of flaws we're always accustomed to seeing. It's just, we have to now understand more about the financial. To your point, that's why you need to understand that space, is because that's what's going to give you the context to find like really interesting bugs. And even though, like I said, this flaw wasn't technically that challenging in terms of like how it was used to manipulate and ultimately steal BNB tokens, that requires a nuanced understanding of of the way this works. So that's what I'm trying to say. If I can speak today, that's what I'm trying to say.
No, it's good, and we talk about this all the time, right? Like when you're doing a code review, when you're doing an assessment, I would almost argue that about half the time is spent actually doing background and research, especially for new technologies, new risks, like figuring out what the threats are that exist in an application, or in this case with a chain with a specific smart contract, is going to take just as much time as it is digging through the code, like understanding what the code is doing. And as a security person, that's typically what you're paid for, is that, being able to take those threats and distill them down into actual attacks against this specific custom piece of code. So just be aware that that's the case. We're going to talk a little bit more today about other people's experiences doing code reviews, which, it's interesting. We definitely have our opinions there, obviously, but yeah, let's talk about the cryptocurrency, or this attack specifically first of all. And you'll notice in this case, right, it was like about it's BNB, approximately 1.8 million dollars was stolen and transferred off, and it occurred a few weeks ago, April 15th. Looks like Reiki might be a more Asian based cryptocurrency, right? But I realistically, I don't know. I haven't used it. So okay, so the TLDR here, right, is that the attacker found a vulnerability in the source code where they were able to make unauthorized changes to the contract addresses. Now, why is that important, right? Part of what this smart contract was doing was retrieving specific cryptocurrency amounts or current values based on an Oracle address, right? And I'm trying to see the code here. Ken, is this what you were looking at where you saw the external?
Yeah, so let me try and zoom in there because that's kind of, yeah, that's the exact function right there where it's listed as an externally accessible function.
See if I can, yeah, there we go. Yeah, okay. So you've got this externally available function, this set Oracle data, right? And what the attacker then did is rewrote set Oracle data so that if I can't remember if they overvalued or devalued the Oracle price for the token that they were targeting, but it'll talk through it here shortly, right? Yeah, so they replaced it, the set Oracle data function, with one that was malicious. So because it can be called externally, the Oracle itself or the contract itself called the malicious set Oracle data as opposed to the one that was trusted, right? And so by modifying that price, they created an arbitrage instance where the function allowed for, I believe it manipulated the price, right? And then they borrowed more tokens available than, the second transaction, a large number of tokens were borrowed. Man, I feel like I'm stumbling through this, Ken.
No, yeah, that's exactly right though. It's basically like the R token value was supplied, it was modified, makes it look like basically they have more collateral. A small amount of collateral was basically supplied, and then that collateral gave them the ability to borrow effectively
Was
bunch
overvalued.
Yep. Yeah, tokens, exactly. So then they stole
yeah,
those
so then they use that to buy a
through,
bunch of tokens,
right?
Transfer it off to another wallet that was, somewhere else, and then walked away. Right? And realistically, they probably could have done this multiple times and made off with more money. That's what we've seen in the past people do, right? Yeah. Okay, so they laundered the stolen tokens, in batches after that. But realistically, it was this transfer of one BNB, and then all of a sudden you see them transfer money out of that specific cryptocurrency based on the value of that token, because the token value was overinflated based on what the smart contract was saying, because it was using that set Oracle data to figure out what the price of that token actually was and how much they could borrow based on that. Realistically, it's fairly basic, right? It's a matter of where's the exploit. All right, there's an externally available function that we can control. How is that used in a security specific or a business specific way? And can I do it multiple times? Is there a way that I can transfer that money out? Everything else is just typical transfer of tokens between different chains, right? There's nothing malicious about that. It's that set Oracle data, that one small nuanced function that was externally accessible and changeable that caused the whole issue to occur.
Yeah, to pull that off, you need to have pretty deep knowledge of, like I said, how all of this works. But one thing I thought was interesting, when you look at the remediation, they have I would sort it into technical and process. And this is something we saw before with an online retailer that you and I had done work for, based on the East Coast, pretty large, online retailer, where they were seeing this issue with coupons. And coupons are weird, man. Coupons are a whole other area of fraud that is just fascinating to me. Every time I for one reason or another, end up digging into it. But anyways, why I say that is they had, rate limiting wasn't the best, but there was some level of rate limiting. And in the end, like there were some, again, speaking to this retailer, there were some technical bits that they introduced to prevent, the abuse of coupons. But ultimately, really what came down to being effective, and it's similar to what they're doing here, is putting limits on things and then having some manual review of anything that kind of looks like it's signaling for a manual review. And that's more, in my mind, of a process improvement versus a technical one. And they're doing similar things to that in the sense that they're like, introducing time delays, time locks on administrative changes to code, as well as capping the borrowing and limiting amounts. And so these things to me are not as much of a technical introduction as more of a gate that they're introducing in their processes.
Yep.
And so I always, I guess why I'm highlighting that is the answer is not always more clever tech work. Sometimes it's very simple. It's just introducing a very simple process. And I think that's okay. I guess that's why I bring it up. It's because we don't talk very much about that. We always talk about, here's your technical fix, here's your remediation advice, et cetera, et cetera. Rarely do we talk much about, especially because we deal with code, rarely do we talk about like, hey, here's some simple things you can do. Review mass transactions on coupons. Just gate it. Don't do it automatically. Have people literally eyeballs looking through to validate and make sure that it's fine, and then approving manually. Just that one introduction of that step saves tons of money and prevents fraud.
Yeah. And I mean, we go back to this, right? Like, okay, so if I go back to my time in the bank, right? Like there was always this issue with, we want things to run as quickly as possible, right? And we want to automate processes in order to, make the flow of money easier, especially in those conditions where it's approved and everything like that. I mean, if you know anything about how banking is set up, there's typically a wires desk where they manually actually process wires. A lot of that is still a manual process because there is so much money that moves back and forth. Yeah. Okay. So I remember a time when we first were assessing like the wire system that they were providing to clients that were making large, wire transfers, found a Sql injection vulnerability in that wire transfer system that would allow us to make wire transfers as anyone else that was in the system. Right. And you would not believe the amount of pushback that we got from the wires department when we said, hey, until this is fixed, you have to manually verify every single wire that's going through this system, right? Because I'm like, you have no ability to trust that wire is coming in is valid and is coming from a customer. Like we were pushing them back 5 years because of the lack of security built into that application. And that process, yes, while it's painful for a smaller, for a number of people to actually perform that sort of verification, it also is the sort of thing that we look for in a MFA environment, right? Like multi-factor authentication. Hey, were you really the one that requested this transfer to occur? And if you did, then you're allowed to push it through. But part of the issues that we're having in the Web3 space, and I'm getting here, right? I'm getting there, is that we are trying to make these environments so quick and the ability to trade to take advantage of arbitrage opportunities from an investment perspective that we're missing out on the manual checks. So you look at what happened with Terra Luna, and it's because that is an automated, the stable coin that they introduced, that USDT, right, was backed by an automated system that would purchase Bitcoin to keep the price of USDT stable. So the second that it dipped below a certain threshold, the automated system couldn't keep up and caused the crash to occur because there was no liquidity available to actually buy. Like the whole system that happened, the whole crash that happens with these is directly related to the automated systems that we put into place. And so, Ken, I was just going to your point, right? We have a tendency to trust these automated systems, and we want to be able to do this very quickly so that we can make lots of money in those cases when arbitrage opportunities exist. but it also bites us, and it can cost us millions, if not billions of dollars, and companies go under because of what happens.
Yeah. And it's not, I mean, like, one thing they said here was, like, hey, the source code of the platform will be reviewed frequently for any major changes in code. But it's like, that's great. That's not necessarily the answer. I mean, it's one thing. Man, security's weird. It's such a multi-pronged approach that you have to take. But again, we're doing something new. Centralizing decentralized apps for financial transactions, making them performant, doing this both in I mean, you talked about the infrastructure being quick, but it's also the speed of development, right? I mean, we're trying to knock out features and get things written and, compete, be competitive. And so it's like, yeah, I mean, it's just not, to me, it's more of a, it's more of a process fix in some cases to prevent the technical problems from cropping up, I guess. But yeah, no easy solution. Obviously, as usual, in the software security world, there's never an easy answer, or rarely an easy answer. So this will continue to occur. That's my prediction for 2022 and for 2023 and for 2020. Now I just keep going. Like it'll continue to be an issue for a bit.
Well, and this
however,
and this is where it gets even more interesting, right? Because we have smart contracts that actually execute based on inputs, right? Like you call a smart contract, and as long as the conditions that are met, as long as the conditions are met that are in that smart contract, it runs, and those are embedded into each of these cryptocurrencies, right? And into these blockchains. Right? That functionality is extremely powerful, but it does cause these problems to occur. So when one of these problems exists, they have to go back and rewrite the smart contract. They have to update the chain. At some points, in some chains that requires a hard fork, right? It's not an easy process to roll that out across all their nodes. But on top of that, we have distributed apps, right? And the distributed applications that run and use those blockchains to perform other functionality have their own set of inherent problems and security issues depending on what you're trying to do there. So there's a ton of space here for people to play, if you're listening today, on like specializing in secure code review or specializing in Web3, security in general, because we just don't understand all the implications yet. It's like when we started with mobile applications or the web. It's going to continue to be a problem, and there's an opportunity for someone to come up to speed quickly and really do a lot of good work. Anyway,
do you want to know an interesting fact that I just learned? The first recorded financial fraud occurred in 300 BC, according to what I'm reading right now. Because I'm looking this up because I'm curious, like, how far back does financial fraud date? Like, we talk about, again, this is like, because I was thinking about it, like, yeah, there's technical aspects, yada, yada, great. But financial fraud has been occurring since money was a thing, right? So my question is, how far back does it go? What were the methods used pre-technology being introduced? And, how does that apply to today's age? So probably not something we're going to get to in this podcast today, but it's something that's interesting to think about. It's just like, hey man, financial fraud's been going on forever. How this is just I guess what I'm saying is this is a new space technically with Web3 and the blockchain and decentralized apps and all of this cryptocurrency. However, I don't really think I think it's the technology's new, but probably the same issues are going to hit them as we all learn this together and figure all this out together. Although there's no reason to introduce, learned lessons once again, right? So we don't need to introduce flaws, things we've already learned from past mistakes, again, technically. So anyways, something I've been thinking about is just like, what's the history of fraud here? Sounds like an interesting talk. Something
it does.
think
Yeah,
about.
I mean, it would be, right? Like interesting to go through and look and see how that fraud's actually been executed, right? Like taking it about, I mean, realistically, we're going back. Like, so does this mean security, like, application security or, cyber security, Ken, goes all the way back to 300, but you saying BC or
yeah.
80 BC?
BC, yeah.
Yeah.
Well, no, and like there's some stories here about like Ulysses S. Grant was wiped out due to having helped his son Buck with some failed business stuff. Oh man, funds of the funds.
So we're gonna pivot to be a financial security podcast. That's what you're saying, Ken, instead of
Why not? I mean, we're in that space. Got to understand the full context, even if it goes back to 300 BC.
Exactly.
I'm a professional, Seth.
There we go.
I go back that far for my context. Yeah. No,
what, you're not going back to 300 BC? Gosh.
I know. Are you even doing security right?
Yeah.
No, this is super interesting, actually. Like, okay, I'm just gonna go ahead and post this article. It's pretty interesting. It's on Investopedia. But yeah, no, like fraud goes back quite a ways. So pretty interesting stuff. All right, so moving on from this, I think we probably beat this horse to death. We had another topic of interest. Let me pull it up.
Do you want to talk about Cancer's blog?
Yeah, that's exactly. That's what I was going to pull up. So this was actually put in our Slack chat last week.
Yeah, it was.
And wait, can you disclose your relationship?
We know Ken through specific other channels. I think that's about all.
A different
we can
Ken.
say on that.
Ken.
A different Ken.
Yes.
Whose blog post Ken. This is. Yeah, here.
I'll drop so let me put it in here.
Oh, I just did. Yep, I got it.
Oh, sorry. I was late. Sorry about that. I don't know if I can delete
put user in timeout. No, you can't. Yeah. It's fine.
Block user. Block myself. Cool. I'll put it in the general of our Slacks. Or actually, I don't need to do that because it's already in there. Anyways. All right. So
yes. So this popped up and there's been quite a bit of a discussion about it, right? And I know Ken, over the course of his career, I think this is all coming based on, I think somewhere he said between 20 and 30 different security audits, right, in the last 5 years that he's done. Yeah,
I think we're actually pretty well set up to talk about this because both you and I have done a lot of consulting for small startups. So I actually think like this is probably an area that we might be the most knowledgeable on and like have a ton of experience on. And that's, hopefully helpful for folks to, I know that. So let's give a brief background first on this article there, Seth. You want to run people through like, what the idea is here, the summary?
Yeah. So Ken is just talking about like he's got, I think, 8 or 10 observations about finding bugs in source code as he has reviewed it and his experience with what code looked like, and and then the deeper, like just kind of, it doesn't feel like it goes in very deep into what those bugs necessarily were outside of general observations, right? Which is always interesting to you and I from a code review perspective, because we have done so many of them and our experience, your experience may differ. I know Logical actually had like a response that he put up to this too. Stefan did. On Lobster of all places.
Yeah, so I've seen like more. Oh, right. He probably has a more in-depth one that he's responded to. But I will say, out of all the items listed here, and I think there's like how many? 16. Sorry, 16 items that are like the common, patterns that they've recognized from working with those startup companies. 3 and 5 seem to be the most contentious. So the third one was our highest impact findings would always come within the first and last few hours of an audit. And I have some thoughts there myself, actually. I shamelessly will admit I have not yet gotten to Stefan, so I'm actually interested what his takes are. So that's number 3. Number 5 is all the really bad security security
Yeah.
vulnerabilities were obvious.
Yep.
We'd find the big one, a vulnerability so bad that we call up our clients, tell them to fix it immediately. So probably a fifth of the code audits we did, we'd find the big one. Okay, so 1 out of 5, they find a massive vulnerability. They'd have to contact their clients immediately and tell them to fix ASAP.
Yes. Well, and maybe what we should do is just step through each of these really quick, right? Because some of it does line up. You're right. 3 and 5 are probably the two that we're going to spend the most time on, because I do have opinions about that as well, right? Like we obviously do. But yeah, is that how you want to approach this one, Ken? Or is there a different?
Sure, yeah. And like, I think he also mentioned business logic flaws were rare, but when we found them, they tended to be especially bad. Stefan kind of commented, hey, that's maybe more of a, could be more of a depth issue. But anyways, yeah, let's dig in. I'm interested to hear your thoughts first. And if I have anything to add, then I'll add.
You will. Okay. So my first impression is I'm in agreement with a lot of this, right? So you don't need a large team. Simple outperforms smart, right? Like simple code, like keep it simple, stupid, right? That whole, saying is entirely correct when it comes to security in source code. The applications that tried to do things in a complex manner, that tried to re-implement the wheel, were the ones that they're the ones that definitely have the most problems, right? Writing secure software has gotten easier in the last 10 years. Yes, I would definitely agree to that. And then secure by default features and frameworks, right? That goes hand in hand with it. Mono repos are easier to audit when you can see all the code, it's easier to deal with. You could easily spend an entire audit going down the rabbit trail of vulnerable dependency libraries. Yes. I don't know what else to say on that one, because I don't think you and I have ever really been asked to audit third-party libraries, right? I don't know. In your experience, do you do that in your current organization? Is that something that you expect your product security team to do, is audit the third-party libraries?
So not normally, but only that. Yes, I have been asked. So yes and no. So for the most part, no, but yes and also ours is going to be a little bit different, because some of the libraries let's talk about where I work, pre-acquisition / hiring of our security lab, sec lab. So pre them, when we had some pretty substantial changes, like think the way we're rendering, say, Markdown to HTML, or the way we're handling some core component of authorization, or something like that, right? Something pretty impactful if insecure. In those cases, yes, our team would be asked to review those changes in a library. And I'm not sure that anything super fruitful would usually come of it. I think more so what we realize is there are certain ways of using libraries that are more secure than others. And so that kind of usually was more of an outcome more often than not. But now we just kind of say, hey, let's have our sec lab folks dig in on it. And if they find anything, they can report. They have obviously pathways for reporting responsibly to maintainers and getting things fixed and all that. So it's actually way better for us, I think, and not just for us, but I mean us collectively as a community.
Yeah.
So that's how to answer that. Now, having said that, in a past consulting life, we certainly came across some cases where people basically had forked libraries. And then those get outdated, and they have CVs discovered later, and then those CVs still exist in the forked versions of those libraries. But also sometimes you're looking at libraries not from the actual code perspective, digging into the code, but sometimes it's more of just hey, let me look at especially we talk about this with cryptographic libraries and things like that, where you want they want them to be in use and well vetted. But if it's like, 5 watchers and 3 forks and, 1 star and not a whole lot of activity and came out of left field, then that's usually pretty, meaning like by someone who's never previously contributed to the open source community before, and this is their first package. And so those are the other avenues. That's a long-winded answer, but those are the scenarios I've reviewed packages for.
Yeah. And I mean, as far as package review goes, yes, you can definitely spend a lot of time jumping down that rabbit hole. I don't personally, that's been a less interesting rabbit hole to me especially from a secure code review or from a code review perspective, because it's not necessarily the scope of what the developers have turned over to me, right? Yes, they're using, if they're using one of those packages insecurely, or you find it via dependency check or sneak or, one of the other SCA tools that are out there, great. Let's get them to upgrade it. And we do see outdated packages in pretty much every code review that we do, but it's not necessarily some place that I've spent a lot of time trying to exploit or trying to find out why those vulnerabilities or if they exist, because it feels like it's already covered space from my perspective, right? I'd much rather look for business logic flaws. I'd much rather look for authentication or authorization problems in the custom code that I am reviewing, as opposed to digging down that or jumping down that rabbit hole. So I mean, that's one of those that I'm like, I can see how someone would get excited and jump down that rabbit hole, but it's not necessarily one that I've been tempted by. Right.
Yeah, I mean, there's a lot of factors, like how significant is the library, how much time do you have, how big is the code base, things like that. Smaller code base, lots of time to review, and the library is pretty impactful.
Yep.
Maybe even the whole basis for which the app is built upon. Yeah, I'm going to dig in. But otherwise, and especially if there's CVEs that are critical and high, of course, I'm going to see if those are like exploitable. Okay. But otherwise, yeah, it's not of a huge interest. Usually there's too many tools to kind of cover this. And usually what's the fix? Upgrade, update.
Yeah, exactly.
Or even change the way you're using it in a very minor way in your configuration. Yeah. So it's never usually that serious.
Okay. Yeah. And then, some of these, he gets pretty specific in jumping into, I probably should have shared that screen here, but he jumps into, deserialization vulnerabilities, untrusted data, custom fuzzing. I would agree with, like, every time I've done custom fuzzing, we found something interesting. But it does take a fair bit of time to actually get to that point. And to his point as well, you don't always have a fully buildable project because of web services or mono. Like, it's not like a single package that you're looking at. So running tests and modifying tests is surprisingly effective for me as well, in order to fuzz out those different vulnerabilities. And
you use Sputter before.
Yeah.
I mean, if people aren't familiar. Oh,
yeah. Yep. Sorry. Yeah.
No. I thought you were talking about it. That's why I shut up. I was like, they're about Sputter.
Yeah, that was 2014 when I wrote that framework, right? That does, basic, fuzzing analysis of web applications, right? And sadly, I haven't had as much time to maintain that. Obviously, like most open source software, but it did, warrant some interesting results. I mean, every time Stefan and I work on something, or Logickill and I work on something, especially in like the crypto chain space, we've played with quite a bit of like Redamsa and libfuzzer, and actually using those different libraries to suss out exploits and suss out vulnerabilities in the source code. And we don't always take it all the way to actually exploitation, but at the very least, you can find things pretty quickly in an automated fashion. So I guess what my takeaway then is that most of this we agree with, right? Like it lines up pretty closely with our experience. But let's talk about those, that number third, like the highest impact finding would always, and this is the language that Ken uses here, would always come from within the first and last few hours of the audit. Is that your experience?
It is and it isn't. And I'll tell you
Okay.
why. So, because I was thinking about this. So, like, right. In scenarios where, oh man, so this is like kind of this is a difficult one. But it's not all, first of all, let me just start with, that's not always true. It actually is highly dependent on kind of what you're working with, how much time you have, what kind of review you're doing. That's completely dependent. So my most impactful findings don't always come at the end, but when they do, it's typically, oh man, sorry, I didn't realize my camera was so off. Let me fix this. I was like, I think the whole time I've been like out of camera anyway, or out of focus. Anyways, what was I saying? So when it comes at the end, that's typically like, I'm gonna be honest, usually when it comes at the end, it's because a scanner has been run. You've already collected all of the information that you needed to about the application. You've already looked through the code. And so when you review this, which is what we actually recommend this, and I do this, I always run a scan at the end, at the very end, because by then I have all the context for what I need. So when I run a scanner and I get all these findings, I could say like very easily, oh, that's, connected to this and that. And so maybe it's exploitable, maybe it's not, but I have a better understanding of the application. And so those findings make much more sense than if you just like scan right away. And then you're like, oh, cool, I have, this, that, and the other, but I have no idea like how this application really works yet, or its tech stack, or, is this function that's potentially vulnerable even used elsewhere in the code, stuff like that. It's just hard to gauge. It makes sense that the beginning and the end in that context. So in the beginning, you say, let me look through. And as you're going through, just getting to know the code, you're like probably immediately going to find some low hanging fruit that's interesting. Like we do that even when we've done the After Dark episodes, which we have. That's what I forgot at the beginning of this episode. That's what I forgot. Wednesday, we have an After Dark podcast episode where we're going to continue our last review we were doing on Vault Warden. Anyways, now that that's out of the way, thank goodness. I knew we would get to it eventually. Anyways, during those reviews, what you see is like, as we go through, like, oh, we're kind of making notes because we're like, yeah, that's actually an issue. That's actually an issue. This is interesting. Making notes, but not digging down into the rabbit hole. So that's just because you're getting to know the application. You're going to see some things that are low hanging fruit right along the way. But at the end, if you're running a scanner at the end, you also, like I said, have context. So that's going to make it seem like your most impactful stuff came at the beginning and came at the end. However, I'm not sure why the most impactful, the highest impact findings would come in the beginning and the end. Yeah, maybe because the highest impact finding, maybe if you're getting to know the application, you see some, mass assignment or SQL injection or something that's very obvious. Yeah, maybe that, or XSS even, something that's very easy. Like you're looking through the templating language and you see like, HTML safe or pipe safe or whatever it might be. Or using operators, template operators that are, passing things, without encoding it. So that does make sense. However, why I'm saying all this is I'm getting to the point that, yeah, in those kind of reviews that can make sense. But honestly, one of the things this is coupled with is their sort of like statement about on item 10, business logic flaws were rare. The problem is that business logic flaws are usually the most impactful flaws. Authorization or business logic flaws, those kind of two go hand in hand. Those are the things, especially in a mature application, that those are going to be your most impactful findings, and that only comes through really going deep and spending a decent amount of time inside the application. And so, if you're time boxed and very limited, and you're just trying to get through the highest impact stuff like quickly, I could see why at the beginning and the end of an assessment that would happen. But if you're going for a multi-week in-depth assessment, usually business logic flaws and authorization flaws are the number one thing that are the most impactful and crop up the most. But again, only if you have a decent amount of time spent during that review. So I don't know. That's kind of my like extended thoughts on it. I don't know.
Yeah.
What are your thoughts there?
Okay. So the low hanging fruit, right, is you're doing your information gathering. Yeah, I definitely agree that so I take a little bit of, I don't know if I would say the highest impact findings come within that first and last few hours of the audit. I would say, you find the largest number of findings within the first few hours of an audit because of the low hanging fruit. So whether or not those are the highest impact, I don't know if I necessarily agree with that, because finding the highest impact at the beginning and the end almost points to me a lack of real process during the middle of your assessment, right?
Right.
So if we really understand and we do our information gathering properly, yes, we're going to find some things during those first couple of hours. We're not necessarily going to dig in until we get into the meat of the code review in those, like if I break it down into a week, right? Like say I only have 40 hours to review review an application. The first day, as I'm doing the information gathering, yes, I'm going to find that low hanging fruit. But as I step through each of the different processes after I understand what the framework is doing, how it's accomplishing different tasks, I'm going to find those high impact vulnerabilities like the business logic flaws stuff as I'm going through each of those different traces. And I don't think in general, like the last hour of the last couple hours of an assessment, I've ever found something that I would consider to be a critical vulnerability in an application. Maybe once or twice over the course of my career. Most of those seem to come within the first half of a code review, right? That's where we would dig into it, find some of those things that we identify via code smells, right? Like this looks bad. And when I finally dig into that code smell, that's where we find those business logic flaws and other things like that. But I don't think the high impact ones have come in the last couple of hours of an assessment. Yes, maybe, to your point, when you run a scanner, but that's where I kind of differ on this statement in and of itself, as if you're not finding things throughout the whole code review, what are you doing? I kind of question what the process is. I don't know if it was kind of a long-winded, answer on my side, but
no, like yeah, I mean, and to be clear, they do say the last few hours, because I could see if you're saying at the end of the assessment in the sense of like the last few days, because a lot of times, like to your point, I'll find a decent amount of things that are just, I don't know, they're just hygiene things. They're not that interesting. They're just sort of like, oh, there's another thing. There's another thing. Oh, this is interesting. Whatever. Writing that down in the very beginning, but then like towards the end, and when I say the end, I mean like if it's a 2-week assessment, we'll say the last 4 days before the report is due to be put in, to like peer review within your organization or consultancy or whatever. Then I will say that's when I do tend to find the really interesting stuff, but that's only because I personally am like probably one of the weirdest people doing code review, in that I actually don't even like to find bugs in this is gonna sound weird, but I have no interest in really finding bugs if it's a 2-week assessment the first week. That's not really my interest at all. I spend so much time getting to understand the application, the technology stack, the language. I mean, I was talking to you about how I've done that recently, how I was like interested in a language and I started digging into the nuances. These are weird things, or it's at least uncommon, I think, to spend that much time during a 2-week assessment. But having said that, what ends up happening is I do find super interesting stuff, not because like, I'm so awesome or anything. It has nothing to do with that. It has to do with investing so much time and just like learning.
Yeah.
And then once you learn, then it's easy to connect the dots and be like, oh, this and that combined together. Because that's the other thing too. When we talk about impactful vulns, sometimes it is just like, a one line of code change that like it was a super. I mean, he even talks about it in here where he says like all the really bad security vulnerabilities were obvious, kinda, but sometimes not. Sometimes it's like 3 things that are so not super obvious, and then you tie those together, and that becomes the really impactful bug. So I'm gonna have to say that one. Again, circumstantial. It could be true, but like a lot of times, that's not just some super obvious thing. But again, that comes down to like your process and what you're looking for, and I'm sure is very super specific to the person.
No, I mean, it definitely is. And this is like, this kind of goes back to the whole reason why we teach the secure code review stuff is because our approach has worked from a, a general, like, we are assessing lots of different code languages and code bases, and we don't, like, we have to come up to speed quickly on a specific technology, on a specific business need. And that is going to require the investment up front to understand what's actually going on and what threats actually exist, right? Like if I'm looking for the OWASP top 10, yeah, I would probably agree, right? Like finding injection flaws, right? If that's the only thing that, that I'm looking for, or from a bug bounty perspective, you're probably spot on, because those are the things that you're good at, that you can identify quickly and move on. But from an organizational perspective, if you're looking at a code base holistically and trying to identify as many impactful vulnerabilities in a code base in a certain amount of time, you're going to be looking at not just injection vulnerabilities. You're going to have to spread out that time across business logic flaws, against authentication, against authorization. And if you're not finding something in those different items, I start to question whether or not you really understand the application and the framework behind it, or if it's just we didn't take the time up front. You and I always talk about, don't go down the rabbit hole too quickly. It's really easy to get excited by the initial 2 hours of looking at an application, and you found SQL injection, and now the only thing that you look for that entire 2 weeks is injection vulnerabilities, and you miss authorization, you miss other things because of that. I think it's all experience. It's all what you've been looking at, what code bases you get called in to take a look at. But I don't know, right? Like, everybody's experience is going to be different too. So
I do want to touch on, so by the way, I do, first of all, I want to say, like, I do agree with quite a bit of the list. So I don't want it to be like, oh, I disagree, whatever. No, there's just a couple of things like I have a different perspective on. One thing that I thought was really interesting, and is actually, when I think back through my memory bank, is actually really true. And I didn't think about it. But the first item there, you don't need hundreds of engineers to build a great product. And essentially what Ken is saying is that sometimes the most impressive products and the most impressive output, frankly, were done by smaller teams. And actually, this kind of makes a lot of sense when you think about it, right? Like I was thinking about how, I watched a company grow from small to large, or I'll say medium to large, right? Not ginormous enterprise scale, but large enough, right? And what's interesting is that with time comes, the need for more mature processes, more documentation, more this and that, more of this ancillary work that's not the core of what, an engineer does, right? At least not an engineer in a small, kind of scrappy, getting the best product they can get out the door type environment. So it kind of makes sense that like the smaller teams are a little bit more effective, especially when you consider usually at smaller companies, who are the first people that come through the door? They're typically this is the pattern that we've seen over and over again. The most talented people come in the door, they build something great. Infrastructure gets built on top of what they built. Then a company eventually scoops them up, or they go public or whatever, right? And so now there's added pressure and added, need for this, that, and the other. So things grow. Those engineers decide what, like, probably time to move on. I want to do my next challenge. They got bought out. They got money. They've got opportunity to go and do something different. And what happens? Well, that's what they do. So now new engineers come in, different wave of engineers, maybe not the same as those engineers. And this just repeats and repeats and repeats as the whatever the organization grows. So it makes sense, but I never really took the time to really think about it. So I'm glad you wrote that down. I thought that was really interesting, and just a great point.
Well, and I mean, his first 2 points there, right, with the the small teams can accomplish great things, and keeping it simple kind of go hand in hand, right? We have a tendency to over-engineer solutions. We try to solve problems we try to write code that solves problems for every possible condition, as opposed to, hyper focusing on what our business process is, what it is that we're trying to accomplish. And then once the team grows too large or grows larger, it's almost like it becomes unwieldy in both security perspective and product perspective, feature perspective. Like you start to try to solve things that customers haven't asked for yet. Like there's just that fine line of what you're trying to accomplish as a business, what you can provide to your customers that is also secure and functional and reasonable and profitable, right? So yeah, those first 2 points I couldn't agree with more. And actually most of the list, I know we're in disagreement on some of these things, but it's really not, it's more a nuanced approach, a nuanced disagreement than it is a general like, oh, we'll throw it all out, because Ken's got a good Ken has a good head on his shoulders for sure. And
the Ken that wrote this, not me.
The Ken that wrote this. You do too.
I have a terrible head on my shoulders. Yeah, some days are better than others. Some days are better than others. For number 7, though, by the way, I get why he's saying it's easier, but I will say there have been times where discrete applications that do specific things are actually much easier for me to review than some giant mono repo monolith, where it's like, some giant monolith, man, where it's just like functions, or especially you see this with the dynamic languages where stuff is abstracted in such a way where going down the rabbit hole becomes this whole thing, and you got to like fire up your console, find where things are defined. It's a mess. Whereas like discrete services written in like languages that are easier to follow, in the sense that it's not so abstracted, and things are clearly pulled in from packages, and clearly, where everything's defined, where everything that's being called is defined at. And it's easier almost in a sense, and sometimes to see, like, let's say there's, one app that they want you to look at, but there's 3 other services that are kind of, necessary to review because that one app depends on different functionality inside those other things. So to me, sometimes that's actually easier to review, because each thing, especially when it's well documented, what each thing's purpose is. And again, they're written in a language that isn't so like flexible and fluid, like a dynamic language. Like one of the things that I like is like Golang, for instance. I like reviewing Golang. I think it's very straightforward, very easy to review. And so this would be an example of a service that's like pretty discrete in what its purpose is, an app that's written in this language that has like a discrete purpose for the app, along with a very easy to follow along language. Sometimes that's much easier for me to do than some gigantic monolith that's some dynamic language.
Yeah. So. Well, and I would even argue, right? Like, if you look at some of the frameworks that are out there, like the web frameworks, or a RESTful API bolted onto a monolith that's written in, Java, an old, Java Spring app, or an old Java Struts app, or a .NET Core application, or a .NET ASP.NET, right? Like if we go back far enough, those get overly complex, and trying to map out, like in your head, the interactions between each of the different functions and each of the different calls, how input is actually traced, becomes a very difficult process. On top of the fact that they don't always write unit tests, they don't write integration tests for that, or like testing is usually pretty weak. It's just a recipe for, 1, a difficult secure code review, but 2, also a recipe for vulnerabilities that are edge cases that you need to write some sort of a fuzzer to actually find. And that's not necessarily an easy problem to solve, to your point. So yeah, I would agree with you on that, right? Like assessing a web services environment is almost usually easier, because the developers understand the task at hand, and that's the only problem that they're trying to solve with that one portion of the application. Yeah. But then that does point back to integration tests and other things. So like, I would kind of go back and forth on that one, just depending on the environment that I was looking at, the language, the framework that it's written in, how simple the developers kept things, or how old the code base is.
Yeah.
I don't know. Yeah, I mean, we're not.
Well, no, and to be
so,
and to be fair, this is of course going to be a very subjective list, because it's a very subjective experience. It's an experience. It's subjective to someone else's experience. And to be fair, the sample size is decent, but it's not like massive either, right? So, yeah, on the whole, I agree with a lot of this, but of course, there's nuance in a lot of this as well, because it's very situational. And that's, I think, the hardest part about. I think that's the hardest part about what we do, is that, like I've said before, there's like professions that are, they've been around forever. They've evolved. They have like lots of literature. They have lots of standards. There's like certain things you have to follow. And we're very much in our infancy as an industry. So there's not a lot of established, and there's a lot of art to this as well. Like, even though I say it is a lot of process, it is a lot of, it's a lot of process, and it's a lot of, evolving that process and being very stringent in the way you approach things and being very disciplined. There is still always that element of you need to adapt whatever processes you follow to what you're doing. So there's, of course, always going to be, and also your preferences are different from mine. And so there's that personal sort of approach. And so there is a bit of art to the science as well. Of course, we try to reduce as much as possible and make it a systematic, repeatable approach. But nevertheless, there's still going to be some art in this, so, and some subjectivity to it. So I will say number 16 made me crack up, because like this is literally what we say in every class. We always tell people, like, this is the specific example we give, is like, when we talk about like, hey, doing the scan at the end, like I said earlier, and getting all the context and information gathering and understanding the tech stack and blah, 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 blah. If you're going to run a scanner, that's fine. Just run it at the end so you have all that context. But it's funny because 16 like is the exact example we show, because we're like, yeah, when you run a scanner and it shows you have 5,000 uses of MD5, that may be something. It may be complete and utter nonsense. In this case, he talks about why it's often nonsense, and usually it's fine. Yeah. It has no security impact. It's just being used for something completely different, like random pseudo-randomized GUIDs or something like that. Actually, I don't mean GUIDs in a security sense. I mean GUIDs for like a like database key or something like that. Something silly like that. Yeah. So, not for security.
Cool.
So.
Yeah. Well,
anyways, I mean, we've been going. How did we go this long?
I don't know, right? Like, this is always it, right? We even have more articles because we were afraid we weren't going to have enough to talk about today. So,
we were just long-winded.
Our bitch session for the day, yes, and we are doing a Absolute AppSec After Dark tomorrow evening. Please join us.
Yes.
Yes, it's tomorrow. So we will post that out, join the Slack channel, or watch it later, right? It should be interesting. To be completely frank, I have not looked at Vault Warden since we looked at it the first time. So I'm pretty sure I'm going to have to come back up to speed, and it will be interesting, especially when you have a couple drinks in you, because it's after dark. And yes, we'll see how that one goes, how much we bang our heads against the wall or what we find.
I put the link right now.
Okay, drop it in there. Yeah. Outside of that, jump into Slack and ping me if you would like a t-shirt. We're getting ready to send out that latest batch, and always want to push out swag to our listeners. And we are going to start accepting sponsorships, so listen for that if you're interested, or your company would like to sponsor an episode about a specific topic. You could reach out to either me or Ken at absoluteappsec.com. I think that's everything for today, Ken, unless you got something else before we close it out.
Nope.
Okay. All right. Not at all. Thanks, everybody, for listening. We'll see y'all tomorrow or next week, depending on your preference.
Thanks. All right.
Ciao.